Welcome to our training series on Intel's next-generation firmware initiative, the Universal Scalable Firmware, USF. For this session, we will provide a general overview of USF and its stack. So what is USF? USF is Intel's next-generation firmware initiative to simplify and scale firmware development from edge to cloud, across all layers of the firmware stack, from silicon and system-on-chip, SoC, to platform, bootloaders, and OS payloads. It will do this with modular and flexible architecture that helps enable developers and technology partners to accelerate the integration of new silicon and platform technologies, which will result in efficiently deploying breakthrough products and solutions at scale. USF simplifies firmware development by defining abstraction layers and domain boundaries between SoC, IP hardware, and IP firmware, platform, and operating system, with verifiable interfaces and APIs between the firmware modules. It'll also improve firmware security by enabling consistent support for firmware attestation, authentication, measurement, and secure updates. We often like to refer to USF as a layered cake. Shown here on the left, you can think of the different interfaces and code bases as the layers of cake, and the corresponding API layers as the frosting that binds one layer to the next. On the right, you can see the ingredients that make up each of the cake layers. So let's briefly go over the construction of our cake. Starting at the top is the OS payload interface layer that passes control off to the operating system. The OS payload interfaces have our well-known interfaces such as ACPI, UEFI, or multi-boot, that provide a means to interact with pre-OS and runtimes. The universal payload is an API layer for different OS payloads such as UEFI, Linux Boot, Vault Boot, and Acorn Embedded Hypervisor, plus support for various bootloaders. The platform orchestration layer, POL, is the bootloader layer, sometimes called BIOS or system firmware. This layer is the build environment for the system firmware's platform binary image that is created by and supports several open-source bootloaders, such as Tiano Core EDK2, Coreboot, Slim Bootloader, and U-Boot. This layer typically governs the boot flow from the system reset vector up to loading the universal payload. The POL consists of simplified ACPI support, common libraries for various bootloaders in C and/or Rust languages. It also supports standard binary configuration editing through YAML for the Updatable Product Data, UPD. For security, there is also support for firmware attestation, authentication, measurement, and modern update. The Intel Firmware Support Package, also referred to as Scalable Firmware Support Package, is an interface that provides entry points for the POL to make calls into the SoC abstraction layer, SAL, for initializing the silicon, the processor, and chipset family, or SoC. The Scalable FSP complies with the current Intel FSP specification, where there are APIs for early silicon initialization. It also has updatable configuration data parameters that the SAL uses to initialize the silicon according to customer needs. Future Intel FSP versions will have implementations for SMM encapsulation, unified configuration, authentication, 64-bit reset vector, various domain modules, and SoC level validation. The SoC abstraction layer, SAL, is how the low-level silicon and hardware get initialized, and it provides SoC and platform-level stitching. The SAL consists of a dispatcher through a call table and also has low-level services exposed through the Intel FSP interface to the POL bootloader layer. The SAL is responsible for calling lower-level IP firmware drivers through the Hardware Programming Interface API that in turn directly access and initialize the silicon. These are modular IP firmware drivers and conform to several specifications to shift left their development and validation, thus providing quality low-level IP drivers to initialize the Intel silicon. This concludes our USF overview. For more detailed information on each of the USF layers, please check out the rest of the videos in our USF training series.